Hello, welcome to Oracle Cloud World. My name is Sergio Castro, and I am with Oracle University. Today, we are seeing virtual cloud networks. So let's go ahead and get started. Again, my name is Sergio Castro, and I am a principal training lead. So I do deliver training and evangelist. So this is what I'm doing, promoting our solutions. So let's go ahead and take a look at the objectives. Today, we are going to be describing the virtual cloud network, the resources that we have, like the security lists, the network security groups, route tables, public IP addressing, private IP addressing, and connectivity to the outside world, like the internet or your on-premises. And what do we use to get there? We use gateways, the internet gateway, the NAT gateway, but let's go ahead and actually see them. So this is how a virtual cloud network looks while it's being already configured to completion. And you can see that it resides in a single region. Oracle has many regions throughout the world. When you create a virtual cloud network, it's only on one region, in one region alone. You can have more than one IP CIDR range, more than one IP address space in it. That means that you can have a 10.0.0.0/16, and in the same virtual cloud network, you can have a 172.16.0.0/16. You can have that up to 5. Now, the CIDR blocks can be modified. So if you created a /24 and later on decided that, no, that's too little host that I have, so you can move that to a /16. Or is that too big for you, then a /25 or a /26. So we do recommend that you avoid CIDR overlaps. If you don't interconnect the virtual cloud networks, then it's not an issue, but it's still best practices to have each virtual cloud network with its own CIDR that is completely different from another VCN, even if they don't interconnect. Now, for addressing, we do recommend that you use RFC 1918. Now, this is really important. It says ranges specified in RFC 1918. We do support /16 all the way to 30, /12 and /8 are part of the recommendations of RFC 1918. However, we do not support those. So just keep that in mind. However, you can use any range that you want, even those that are public. But remember that this might create some overlaps with resources out there in the open internet. IPv6 is supported. We provide 1 by default, and then you can bring 4 more, completing 5 IPv6 prefixes that you can use. Now, IPv6 is reachable. With IPv6, you don't need NAT gateways. You don't need to mask. You don't need private address space. There's no equivalent RFC 1918 for IPv6. So you specify a private subnet with IPv6 just by the label itself. This private means that it will not be able to reach resources in the open internet. Now, these are part of the components that we have. When you have a virtual cloud network, however, in order for you to use it and leverage it, you need subnets. You need to divide your virtual cloud network into subnets. And instances like a computer instance or a database node or a load balancer will be residing on a subnet. And subnets can either be public. That means that if they're public, you have the option of providing it with a public IP. It's optional. You can still work only with private IP addresses. If the subnet is private, then that means that you don't have a choice. No choice for you to provide a resource in a private network with a public IP address. Now, there's another category. Subnets can either be regional or availability domain specific. A regional subnet means that in those regions where we have more than one availability domain, the subnet that you create will span all the availability domains in that region. Typically, we have 4. 1 more is coming that have more than one availability domain, have 3 availability domains in the region. So when you create a regional subnet, it will span all 3 availability domains. That means that You can put a resource and availability domain 1 and another resource and availability domain 2. Now, there's pros and cons of having for either way. It will be up to you to decide if you want a regional subnet or an availability domain specific subnet. Now let's go ahead and take a look at the subnet. You can shrink like with the VCN or expand your subnet. You can add additional CIDRs to your subnet as well. Now the virtual network interface card of the resource that you're going to be deploying on that subnet will determine how that resource will communicate to the outside world, outside of the VCN. Now, the subnet comes with a firewall that we call security list. And a security list applies to any node that is placed on the subnet leveraging that security list. And a security list is only for allowing or enabling permissions. By default, every service is turned off except 3 that when you create a subnet, it automatically creates a default security list with 3 permissions. One of them being port 22 is open. That means that you can SSH into a compute instance that you deploy in a subnet that is bound by the security list. And we also have ICMP, 2 ICMP for fragmentation and troubleshooting. If you want to enable ICMP for ping purposes, then you have to go ahead and configure that yourself. Now, the fact that the security lists come with these 3 rules doesn't mean that you have to leave them. If you don't want SSH into your nodes be available, you can remove it. You can have an empty default security list if you wish to do that. Here we can have, and you can see that we have a stateful. We also have stateless, but we'll get that in, with greater detail shortly. Before, let's go ahead and see the details. You can enforce the security list on a VNIC level. Now, it consists of rules that specify the traffic allowed in and out of the subnet. So it works for both ways. Traffic coming in from outside of the virtual cloud network and your nodes, compute instances generating traffic going outside of the virtual cloud network. And I mentioned already these 2. So let's go ahead and continue. Now, I mentioned that we have stateful and stateless. So a stateful rule, when you create a rule that applies for outgoing traffic leaving your virtual cloud network, you don't need to specify a matching rule for traffic coming into your virtual cloud network. As you can see, automatically, if you go from this end to this other end, traffic will be allowed on port 80 in this case, in this example, coming back in. So that's a stateful rule. A stateless is the other way. If you create traffic, if you create a permission that allows traffic going out of your virtual cloud network, if you don't specify the same security list rule for traffic coming into your virtual cloud network, it will not work. A stateless means that you have to be very specific on the traffic that you allow coming in. So this is a stateless security rules. And this is an example. And I mentioned that some protocols like ICMP, you need to specify in ICMP, you need to allow traffic coming in because ICMP is very sensitive. So regardless of the rule being stateless or stateful. Now IPv6 is supported, but you need to be very careful when you deal with IPv6 because if you have IPv4 rules and permissions enabled on your subnet, it doesn't mean that automatically they'll roll over to IPv6. For example, ICMP for IPv6, you need to specify IPv6 ICMP in addition to ICMP for IPv4. Now there's another firewall, if you will, that we call the network security groups. And the way that I like to describe what a network security group is by with an example that allows you to create exceptions. For example, I mentioned earlier that when you create a security list, it applies to everything on every single resource that you have on your subnet. So if you have a subnet with 80 nodes and you want to enable port 80 or port 443 for HTTP and HTTPS traffic, that means that all 80 nodes will support that traffic. But you might only have one web server or two web servers if you have a load balancer. But then you have 78 additional nodes that don't require that permission. So what you can do is don't enable port 80 and port 443 on the security list, but create a network security group and apply to those two web servers. And that will create the exception that when traffic is coming in from the outside or even from inside OCI into your virtual cloud network, this network security group permission will allow the traffic only on those two web servers. Now, you can have a maximum of 5 network security groups per VNIC. And the network security groups and the security lists, you can mix them as you wish. You can even, if you decide to play with stateless security network security groups, you can have the stateless permission for traffic coming in on the security list and the stateless permission for traffic going out on the network security group. So you can work how best is suited for you. Oracle recommends working with network security groups over security lists because it allows you for a more fine-grained detailed configuration. It can get a little bit more complicated, so it's up to you to decide how you want to enable that. Now, the security list, again, it applies to and it's enforced at the VNIC level for all nodes on the subnet. The network security groups allows you to create exceptions, as I was explaining, and you can specify the network security groups of the source of traffic for another network security group. So this is unique to the network security group. So you can nest and configure your network security groups in a way that the source of one network security group is another network security group. The security list does not allow you to do that. The source is always a CIDR block. And Oracle recommends using network security groups over security list. Now let's go ahead and take a look at how is it that we communicate outside of the virtual cloud network. So if you want to reach the open internet from your virtual cloud network, first you need a public subnet, and then you need the internet gateway, which functions like a router does in a real physical network. The internet gateway will allow bidirectional traffic. By bidirectional, I mean that traffic originating from within the virtual cloud network and traffic originating from the internet. You can establish that communication. Again, you required a public subnet for you to leverage the internet gateway. Now, the internet gateway can only be used by resources in the virtual cloud network. If you peer to virtual cloud networks, the virtual cloud network that is peered with the one that has the internet gateway will not be able to leverage that internet gateway. Now, we have additional gateways that have different purposes. The internet gateway sole purpose is for communicating to the internet, public subnets. Now, what if you have a private subnet and resources from the private subnet needs to go out to the open internet and retrieve a patch or retrieve an upgrade? So for that, we have the network address translation, the NAT gateway. The NAT gateway will allow your resources to originate traffic from within the virtual cloud network out to the open internet. However, resources in the internet will never be able to access your resources in the virtual cloud network through the NAT gateway. So the NAT gateway, the configuration looks very similar. As you can see here, the internet gateway has the arrow pointing bidirectionally. The NAT gateway traffic is outbound into the internet. Now you can have a limit of 5 NAT gateways per VCN. Remember that you might have different subnets and each subnet might be configured differently. So there are special reasons why you might need several NAT gateways. Now, the Internet Gateway and the NAT Gateway are not the only gateways that we have in a virtual cloud network. We also have the Service Gateway, and this is a gateway that has a very specific need. Oracle Cloud Infrastructure has several public-facing services like object storage. You can create an object storage bucket, and anybody from anywhere in the world, if you enable the permissions and you allow it, will be able to reach your bucket and retrieve whatever it is that you place there. You might put images, pictures, files, and you can make it available. You don't need a virtual cloud network for object storage. Now, we also have the autonomous database, the autonomous data warehouse, and the autonomous database for transaction processing. And part of the solution, one of the solutions, is to be out in the open internet. But if you are already on OCI and need to reach one of these services, there's no need for you to go over the internet gateway, because that means that you're going out to the internet, then coming back from the internet to autonomous data warehouse or to the object storage. And once you retrieve the resource, you go back over to the internet and come back again. So it's an unnecessary path, because you are already in OCI and object storage and the autonomous database. These are OCI resources. So the service gateway will allow you to bypass the internet and remain on OCI. So this is more efficient. So you need the service gateway on your virtual cloud network. That's what the service gateway does. And you can see it. I don't believe I have an example for that, but I can gladly demo that. Oh, actually, I do. And here you can see it, object storage. And this tan square represents the Oracle Cloud Infrastructure. This is your virtual cloud network right here. You have your bidirectional or communication or origin from the perspective of originating the requests with the internet gateway. You have your NAT gateway with traffic originating from the virtual cloud network. And then you have this one. Traffic is originating from your resources to the object storage, but it didn't follow this path that I was explaining. It stayed within OCI, and that's more efficient. And again, the service gateway is a regional service that enables accessibility of resources that are in the same region. So if your virtual cloud network is in the Phoenix region, or in the San Jose region, or in the Singapore region, that means that your service needs to be there as well regarding object storage. Now, we have another gateway that we call the local peering gateway, and that's within regions. That means that if you want to connect two virtual cloud networks, you leverage that are in the same region. I was mentioning the Ashburn region or the Phoenix region or the Singapore region. In this case, we are in the same region, and we have two virtual cloud networks with non-overlapping IPv4 CIDR blocks. And each one of the virtual cloud networks leverages a local peering gateway within the virtual cloud network, and then you establish a connectivity among them. And I haven't talked about route tables, but we'll address that shortly. But here you can see that the route table indicates that in order for you to get to the other virtual cloud network, and this is the CIDR block, you send traffic to the local peering gateway label 1. And on the other virtual cloud network, when you're trying to reach this CIDR block, you send the route to your local peering gateway that we labeled 2. And that's for local peering connections. So you need several requirements in order for you to successfully connect to virtual cloud networks. Each one of them needs a local peering gateway. You need to have non-overlapping IPv4 CIDR blocks, or non-overlapping. Even if you, by the mere fact that you have overlapping CIDRs, the local peering gateway connection will not allow you to proceed. That's a lock enabled by Oracle Cloud Infrastructure. So you need to establish a connection between the local peering gateways, and then you need to create a route in a route table that will allow you to get to the other side. And then once you have that route in place, you also need to have the security list or the network security group allow you to access the service that you intend to. Now, there's another way of connecting two virtual cloud networks that are not in the same region. In this case, let's assume that this is the Phoenix region and then this is the San Jose, both on the west coast of the US, and you want to connect them. So for that, you need the dynamic routing gateway, the DRG. And the DRG leverages the Oracle Cloud Infrastructure Network and will allow you to connect two regions. It looks very similar to the local peering gateway, only that here the tan square represents one region, and here we have two individual regions. But basically, you have almost the same requirements. Now, from the connectivity perspective, the dynamic routing gateway will allow you to have CIDR blocks overlaps. However, their routing will not be allowed because it's not possible to route outside of the virtual cloud network if the other resource has an IP address that belongs to a CIDR block that overlaps. However, you can add different CIDR blocks to the other virtual cloud network, and then traffic will be allowed to that other CIDR block of your virtual cloud network or your subnet. Now, there's another way that you can connect two virtual cloud networks in the same region without using the local peering gateway. And this is called the, as an attachment over the dynamic routing gateway. And as you can see right here, how it works is that this virtual cloud network is attached to the dynamic routing gateway. We only have one. This virtual cloud network is attached to the same dynamic routing gateway. In the previous case, here we have two dynamic routing gateways. In this case, we only have one. And the route table on this virtual cloud network will route to the same DRG as the route table in this other virtual cloud network. Now, speaking of route tables, that's the item that we were missing throughout this presentation. So the route table will allow you to communicate outside of your virtual cloud network, be that the internet, be that on premises, be that to another virtual cloud network that you peer locally, or to a virtual cloud network that you peer remotely, or through connectivity through on premises via Fast Connect or VPN. Now, traffic between the VCNs or the subnets will automatically be handled by the VCN local routing. So you don't need to specify that. It will come by default. So in summary, that's it. We cover the virtual cloud networks. We cover subnets. We covered the security list. We covered the network security groups. We covered the route table and the different internet gateways. Here we have the internet gateway, the different gateways. The internet gateway, the NAT gateway, the service gateway, the local peering gateway, and the dynamic routing gateway. So if there's any questions, I'll gladly address them. Thank you very much.